Okay, after that digression, let's get back to fundamental network design concepts. We're looking into switch blocks now. So what does Cisco recommend? And this is a fairly new one. And what they say is to restrict VLANs to switch blocks. Now I say this is a new one because essentially it is newer. And when I say newer, I use that term loosely because some people think that new is last week, and other people think new is within the last couple of years. And it's the last variety of new. This is a change within the last few years. Moving fully to layer 3 and getting away from all spanning tree protocol up here, up top. This is a fairly recent design philosophy change. And it's good, everybody loves it, but it is fairly recent. So what that would mean is, if I were to go with layer 3 here, you can't have a VLAN 10 over here on this side and then have a VLAN 10 over here on this side, meaning that they're the same VLAN, but they're broadcasting from one block to another block. That doesn't work within the new architecture. This should not be allowed. It is not good practice. So it won't work because this is all layer 3 up top. And a broadcast from VLAN 10 in one switch block must stay within that switch block, unless it's routed. And this is what Cisco says is good design. The technical term or phrase they use for this new concept is local VLANs, meaning that your VLAN stays within a switch block, by definition. The reason that it's good is you don't have a broadcast from this guy here flying all around your whole network just because it's on VLAN 10, and VLAN 10 happens to exist everywhere. So confine your VLANs to switch blocks. Local VLANs. Keep the VLAN within the block. Don't let them go further. Now, I have dealt with a couple of organizations and evaluated the situation they're in and advised them that this is the way to go. And the response will immediately be, well, that's impossible. We can't do that. Because our organization is huge and our switches are not layer 3. And then they'll also say things like, well, VLAN 10 spans everywhere because VLAN 10 is our Wi-Fi. Stuff like that. Or anybody on Wi-Fi is on the same VLAN, etc. At which point I usually will say to them, it's okay. Well, let's take a moment here, and would you like a hug? Because it's okay to be that way. Because this was Cisco's previous design. Layer 3 switches did not exist before this. It used to be all layer 2. And Cisco was fine with that because it was what we had to work with back then. But the standards are changing. We're in the process of changing. And it's fine, it's okay to have that type of design, but keep in mind, Cisco is going to try to move you to layer 3, meaning localized VLANs. It makes it easier to manage, and your VLANs will not have to traverse as far geographically or topologically. And when there's a problem on VLAN 10, you don't have to troubleshoot all over your campus then. You'll know exactly where VLAN 10 is, and you go to that switch block because issues will be localized there. So even voice over IP, say, that's usually spread around. You have phones with computers attached to them, and people will say, well, we have one voice VLAN for our whole organization. What do we do? And I'll say, that's fine. This is what Cisco now wants you to do. Have a voice over IP VLAN for this group and call it VLAN 110, and a voice over IP VLAN for this other group and call it 111. It'll be a local VLAN. You don't want some VLANs that span the entire enterprise. Cisco wants to push you in the direction of local VLANs. It's just a good practice. VLANs stay in their switch blocks. And Cisco recommends having a management VLAN as well, where essentially one port of every single device, and it doesn't have to be physically, it can be a logical port, but one port of every device comes back to one point, and we'll call it VLAN 1000, say. We'll say VLAN 1000 is our management VLAN. And that VLAN is where you have your IP for management, for secure shell, for your trivial file transfer protocol when you're upgrading iOS, or your syslog messages for all of your traffic that goes from that device for management. Now a management VLAN, once you have it, it's one of those kinds of things that when you're using it, you're going to say, oh, this is the most beautiful network I've ever seen. All of my management is now off-band. That's what that means. Meaning it's completely separate, so even if the network gets hacked, even if they gain corporate access, they'll never see or manage any of the core devices because it's totally isolated. And that's the ideal situation. The reason it does not always work out that way is, in reality, there are very few networks that have the required recent decent equipment to create a management VLAN. I'm not saying they don't exist. It's just that typically it exists in the larger, more wealthy companies that have upgrades, recent upgrades. For instance, I know of a guy that consulted once for Indian tribes in Arizona. And I'm telling you, that was an organization that had one network for all aspects. For the government, for the police, for their jails and libraries and schools, everything, hospitals, it was all on one network. A consultant that finds themselves with a client like this will deal with hundreds and hundreds of switches that are spread far and wide, all makes and models and ages, some of which will have been purchased last week probably, and others will have been in action for 10 years or more. Now there are switches in existence that don't even know what a VLAN is, let alone be able to create a management VLAN. So another good design characteristic aside from a management VLAN to have is separate voice traffic. You've got to separate your voice traffic. It should always be in its own VLAN because you don't want that to get hacked. There are tools out there that'll convert voice to WAV files, and you'd be surprised what somebody with time on his hands could accomplish with some free tools available off the internet. And then finally there's multicast support. This is becoming more and more common. By default, switches treat multicast like broadcast, which means that if you've got an imaging application like Ghost or Acronis, or some other kind of imaging software, it's going to bury your network environment if you use it. So turn on the multicast support. Plan for multicast support. You'll want it. But all these points are the staple main points that Cisco goes for when you're designing switch blocks. Within the enterprise composite network model, in your switch blocks, constrain your VLANs. Now, the last thing that I'm going to mention, and then we'll wrap all this up, is just the operating systems themselves. I just want you to be aware that there are two flavors of operating systems. You can encounter them both in the switch world, the older one and then the newer one. And the truth be told, Cisco invented the router. Okay, go easy on me if you don't believe that, but this is a point that some people will of course debate. But if you want to waste some time, go Google it and type in the question, who created the router? And you'll see that there's a firestorm of argument about it. People actually fight over this. Now, the majority of people will kind of agree that Cisco invented the router, though. What they did not invent was the switch. They acquired a company that had a good switching line. And that's where the CAT OS, or Catalyst, came from. The problem is, everything in the CAT OS is typically preferenced with the set command. They have no modes like global config mode or interface config mode, all these Cisco iOS configuration modes that we're used to. So over the last few years, Cisco's been trying to make CAT OS go away. So now the good news of all that is, you won't be expected to learn two operating systems to pass the exam. Everything is now Cisco native iOS, which means the switch uses the same operating system as the router. Now, typically, all the larger switch models like the 4500 and 6500 can run CAT OS. And I'll say it used to ship by default with CAT OS, and you had to then upgrade it to use native iOS. Nowadays, Cisco ships 4500s and 6500s as all native iOS, and a lot of times you'll even see on the huge switches like a Nexus things of that nature. It'll come with iOS. But Cisco is trying to get everything to native iOS, and they have a definite migration path to leave CatOS and move purely to native iOS. There used to be a switch line, for instance, called the 5500, the Catalyst 5500, and now you can get one of those for like $50, and it's truly amazing. Those things used to cost tens of thousands of dollars, just as an example. So, as you can see, our network world is definitely changing. It's always been changing. That's all it does. We've moved from hubs to switches to layer 3 switches, and now the enterprise composite network model. All of that is good stuff. And again, thinking of the ECN, just think of blocks. We are designing our network in blocks now. Our whole goal with this is to make a more manageable and secure network. We're keeping our local VLANs within blocks, moving to layer 3 architecture to get away from spanning tree protocol at high levels. Spanning tree protocol is going to be around for decades, by the way. Trust me on that. There's no plan to immediately abolish it. It is deeply a part of our enterprise infrastructure. It's here for a while. It's going to stay. But you can see the writing on the wall. It is going away. It is slowly going to fade. And the goal is, overall, to make things faster, safer, easier to manage. And the way to do that is through tuned routing protocols. And the only OS you need to know is Cisco iOS for your exams. So I hope all of this has been informative for you.